Imagine this. You've been dreaming of creating your own digital domain. Maybe a small server humming quietly in a corner of your home, serving your personal needs. A playground where, you have total control.
Absolutely. It's a fantastic ambition.
It is. But that crucial first step, figuring out exactly how to start well, that can feel overwhelmingly complex.
It really can. The sheer volume of options out there, all the jargon, it's enough to make anyone just freeze up before they even begin.
Yeah, analysis paralysis is real.
But that's precisely what we're here to help you navigate today.
That's right. And today, we're embarking on a truly fascinating deep dive. We're looking into those very first crucial steps of building a home data center.
Specifically, the strategic blueprint part.
Exactly. We're pulling insights directly from Chronicles of a Home Data Center, Davi Blueprint. It's a foundational post by Quan Nguyen.
Right, the founder of Skill Wanderer, the very platform that brings you this deep dive.
Yeah. So it's a pretty rare chance to learn from someone who not only architects learning paths for, well, thousands, but also builds his own personal digital playground. He walks the walk.
And our mission in this deep dive is pretty simple, really. We want to give you a shortcut, a way to understand how to strategically plan that initial technical setup.
And avoid those common pitfalls,
Uh-huh.
right? The ones that derail so many projects.
Exactly. And really set yourself up for a genuinely successful, engaging learning experience. It's all about translating that big ambition, those grand ideas, into an actionable, concrete first step.
Okay, let's unpack this then. We're calling this Day Zero Blueprint.
Mm-hmm.
That phrase itself suggests a very deliberate beginning. So what exactly is this Day Zero Blueprint that Quan Nguyen lays out for us?
Well, to really get day zero, we kind of need to glance back quickly at day nice one, which Quan covered before.
Ah, okay. The prequel.
Sort of, yeah.
Yeah.
That was all about the conceptual groundwork, defining your why, setting those high-level goals, figuring out a realistic budget.
Right, acknowledging potential pitfalls.
And as he humorously but very practically puts it, considering the wife acceptance factor, or WAF, basically general household buy-in, that really sets the philosophical stage.
So day one sounds like the mental prep work, like thinking about what kind of party you want to throw before you even buy the first ingredient.
That's a great analogy.
But day zero then isn't buying the ingredients, is it? It's something else.
Exactly. Day zero is that crucial pivot. It's not about the ingredients yet or plugging things in. It's more like sketching out the menu and the guest list for that party.
Okay, I like that.
It marks the shift from those high-level dreams to crafting the initial technical blueprint. Quan really emphasizes it's not about plugging things in yet, not even installing software.
Wow. Okay, so no hardware involved at this stage?
Not physically setting it up, no. It's about a strategic plan for the very first tangible step, what he calls a small-scale proof of concept, or POC.
A POC. So not a full-blown architectural diagram for, like, a skyscraper, but more like sketching out the foundation for a tiny house.
That's it exactly. It sounds like a deliberate choice about what to build first.
And why that way?
Precisely. It's a conscious decision about what to build first, why that specific way, and how it fits into the bigger picture. Maybe your future Kubernetes dreams down the line.
Right. Being deliberate.
It's about being deliberate and avoiding that common trap of just diving in without a map.
This is where it gets really interesting for me. Why does Quan, as the founder of Skill Wanderer, a platform dedicated to practical, guided learning, why does he insist on this strategy before setup approach?
Yeah, it seems counterintuitive sometimes.
For many of us, the impulse is just to start downloading stuff, installing things, getting our hands dirty immediately.
Well, what's genuinely insightful here, and what really mirrors Skill Wanderer's core philosophy, is that this approach is designed to get around a whole host of common frustrations. Firstly, as Quan amusingly puts it, it prevents you from chasing technical squirrels down rabbit holes.
Oh, I think I know those squirrels.
Yeah. We all do. Think of it this way. Without day zero planning, lots of enthusiasts jump straight to buying the biggest, fastest hardware they can afford.
Or downloading the flashiest new software.
Right. Only to realize later it doesn't actually align with their real learning goals. Or maybe it's way too complex to start with.
Which leads to?
Often wasted money and burnout before they even host their first simple container.
Oh, I can absolutely relate to that. My own early home lab attempts sometimes felt more like a digital graveyard of abandoned projects.
And that's exactly what this strategy helps avoid. It ensures your very first effort, that POC, directly contributes to your long-term goal.
Makes sense.
It also helps manage costs and, crucially, learning curves effectively. If you plan strategically, you're less likely to overspend or just get totally overwhelmed by information overload.
And crucially,
It sets you up for an early, motivating win. We often hear about fail fast, but for a personal project like this, succeed fast is just as vital, maybe more so.
that's a really good point. Getting something small but functional running
Yeah.
provides that immediate boost, right?
Absolutely. It counteracts the natural discouragement that comes with tackling complex tech.
So it really is the critical difference between, say, a structured experiment with clear objectives and just, well, messing around.
Exactly. Although, hey, there's definitely a time and place for messing around too.
True, true. But for this foundational stuff.
For this kind of foundational project, especially one leading to a complex ecosystem like a full home data center, structure really is key at the start.
Okay, so let's get concrete. What are the components of this DO blueprint? What pieces do you actually need to define in this blueprint before you even think about touching a power cable?
Kwan lays out several key elements. First, and this is truly crucial for anyone on a learning journey, especially like the one skill wanderer designs,
Okay.
is self-assessment. You need to honestly assess your current technical skills.
Be honest with yourself.
Totally. For instance, if your ultimate goal is Kubernetes mastery, but maybe you haven't really gotten comfortable with Docker yet, then your initial POC needs to bridge that Docker skill gap first.
Right. Don't jump ahead.
It's about meeting yourself where you are, not where you wish you were, technically speaking.
That's a powerful point, starting where you are. I can imagine people immediately wanting to jump to Kubernetes. What's the biggest danger of, like, overestimating your current Docker or even basic Linux skills at this day zero stage?
The biggest pitfall is almost immediate frustration and a feeling of inadequacy, honestly.
Yeah, hitting a wall right away.
If you skip foundational steps, every single error message becomes this huge brick wall, not a learning opportunity. You end up spending more time debugging basic setup issues than actually learning the cool, complex system you aimed for.
And that's a fast track to just giving up.
Exactly. So after self-assessment, you define the scope of iteration 0.
Iteration 0, I like that term.
It means figuring out the absolute minimum you want to achieve in this first technical phase, your proof of concept. Keep it small, keep it manageable, keep it focused.
Laser focus.
Then you move to initial technology choices. Based on your Day-1 research and that honest self-assessment, you decide on the operating system and the container tech.
Which is probably Docker to start.
Likely Docker, yeah. Kwan highlights that, and he really appreciates the massive leap containerization represents over doing things the old way. Manual installing stuff like Apache Tomcat or Nginx.
Oh yeah, dependency hell.
Containerization simplifies so much of that.
Okay, so you've picked the tech based on your assessment and scope. Then you set clear POC goals, right? Something specific and measurable, not just get something working.
Precisely, not vague goals. For example, successfully run 3 different containerized web apps, or maybe establish basic monitoring for my first container, something concrete.
Make success undeniable. Check the box.
Exactly. And then you move to POC hardware confirmation.
Ah, okay, now we talk hardware.
But only to confirm that the low-spec hardware you've chosen, maybe an SBC, an old laptop, or a desktop, is actually suitable for the defined scope of this initial POC.
Right. You're not buying for the ultimate dream setup yet, just for this immediate manageable step.
That's the key. And finally, learning objectives.
Right.
What specific skills or knowledge do you aim to gain during this first build phase? That feels almost as important as the tech itself, maybe more so.
It really does. Learning is the point, after all.
It absolutely is. And this whole structured approach, this is precisely what Skill Wanderer aims to provide, right?
Sure.
A clear, actionable path through complex topics.
Walking you through it.
Yeah. And what's truly fascinating here is that even seasoned professionals, like Kwan himself, who's architected Kubernetes for actual customers in production environments,
Wow.
he still benefits from a small POC in a home lab setting.
Really? So it's not just for beginners then? That's genuinely interesting. Why would someone with that experience still do a small POC?
Because home labs have unique challenges. You've got hardware quirks you wouldn't see in a data center, consumer-grade networking peculiarities, and, of course,
The WebFair.
the WA exactly. It's also especially essential for folks who haven't done ground-up Kubernetes outside of managed cloud platforms like AWS EKS or Google GKE.
Ah, because you don't see the messy bits underneath in the cloud.
Precisely. This forces you to understand the underlying infrastructure, how all the pieces truly fit together in a real physical environment you manage yourself.
Okay, that makes a lot of sense. So let's dig into that start small idea more. It feels like we're always told to go big or go home with tech projects, especially in the cloud-native world. But Quan's telling us to go small at home. What's the hidden power in that approach?
Oh, there are huge strategic advantages to deliberately starting small. Firstly, and maybe most importantly, it ensures a manageable learning curve.
Right. Avoid the overwhelm.
Technologies like Docker and especially Kubernetes have a lot of depth. Trying to learn everything all at once, that's just a recipe for burnout. A small POC lets you focus on foundational skills first.
Like basic Linux commands or Docker fundamentals.
Exactly. Get those down before adding layers of complexity.
That prevents that classic information overload feeling, which can be totally paralyzing.
It really can. Second big advantage, it's low risk, low cost.
Ah, the budget factor.
Mistakes are going to happen, especially when you're learning new tech. It's unavoidable when you're experimenting on free or inexpensive hardware.
Like that old laptop collecting dust.
Right. Those mistakes become valuable learning experiences, not budget blowouts. You can break things, reformat, learn from errors without worrying about expensive gear or critical data loss.
Okay, that lowers the stress level considerably.
For sure, and that ties directly into faster feedback and motivation.
Getting something running quickly must be a huge confidence booster, especially when you're just dipping your toes in these waters.
It truly is. A small-scale POC delivers that tangible success much faster than trying to build some massive, complex setup right out of the gate.
It validates your initial plan.
And gives you immediate feedback, reinforcing that, hey, I can do this. And finally, there's forced focus and prioritization.
How so?
Limited resources, whether it's CPU, RAM, or even just your personal time, they force you to prioritize ruthlessly what is truly essential for this first iteration.
It stops you adding bells and whistles too early.
Exactly. It prevents that dreaded scope creep, which, let's be honest, has probably killed more home lab projects than maybe anything else.
Guilty as charged on past projects. Okay, so if you're staring at a blank page, maybe feeling a bit stuck trying to define that very first small goal for your POC, Quan offers a brilliant default suggestion. What is it?
He highly recommends planning to host your own WordPress site using Docker.
WordPress.
It's a fantastic starting project, especially if you're relatively new to containerization or Docker itself.
WordPress. I mean, that's a real-world application that millions of people use every single day, right? So why is that such a powerful default for a first project?
Well, it's practical, it's incredibly common, and it immediately provides a visible result, which is super motivating.
Okay, visible result. I like that.
Setting it up via Docker involves managing both an application container for WordPress itself and a database container like MySQL or MariaDB.
Ah, so two containers talking to each other.
Right. This immediately forces you to learn about Docker networking, how containers talk to each other. You'll probably use Docker Compose for orchestrating multiple containers.
Making it easier to manage both.
And crucially, you have to figure out how to handle persistent data. So your website content, your posts, your settings, they don't just vanish when you restart the container.
Right. Got to save the data somewhere outside the container.
Exactly. Plus, like you said, you get a tangible, visible result, a working website, which feels great. And it's backed by just tons of community support and tutorials online, so you're rarely left completely floundering if you hit a snag.
That's a brilliant suggestion. It covers so many fundamental concepts.
Yeah.
Multiple containers, networking, persistent data, orchestration.
It packs a lot of learning into one manageable project.
So for your POC scope plan then, you define things like Docker command line basics, maybe writing a simple Docker file or managing persistent volumes as your key technologies to validate learn.
Absolutely. And then you set those measurable success criteria, like website container is accessible via its IP address, or I can successfully log into the WordPress admin dashboard, or my blog post is still there after I restart the containers.
Clear checkboxes, not vague objectives, done or not done.
Exactly.
You know, what's truly fascinating here, especially thinking about Skill Wanderer's emphasis on continuous growth and learning, is this idea you mentioned earlier, iteration, not perfection.
Yes.
This mindset seems critical. Can you expand on why that's so important for these kinds of projects? Why not aim for perfect right away?
It's absolutely critical. Quan really emphasizes that the POC is, at its heart, a learning exercise. It's iteration 0.
Right. The very first try.
It might be messy, it might be temporary, it will likely be imperfect, and that's completely okay. It's supposed to be.
Okay. Permission to be messy.
Totally. Its primary purpose is to learn, to validate concepts, to build those foundational skills, and crucially, to gain confidence and momentum. The biggest enemy of complex projects is often that pursuit of an impossible ideal right at the start.
Trying to build the perfect thing before you even know what perfect looks like for you.
Exactly. This iterative approach, which is really a core skill wanderer principle in action, empowers you to keep moving forward, learning as you go, and refining your setup over time. Build, learn, iterate.
Build, learn, iterate. I like that. Okay, let's shift gears to hardware then. Quan's personal philosophy you mentioned leans heavily into leveraging single-board computers like Raspberry Pis, Orange Pis, or just repurposing old laptops and desktops.
Yeah, he loves the cost effectiveness and honestly the satisfaction of giving old hardware new life. It's very sustainable too.
So what does he actually use himself? What's his current setup look like?
He's a great example of this philosophy. He currently uses an old Lenovo ThinkPad T480 laptop. Pretty standard business laptop from a few years ago.
Okay. Stock.
No, he's upgraded it. Bumped it up to 32 GB of RAM and put in a 500 GB SSD. So quite capable now.
Nice. And alongside that,
Alongside that, he has a pretty powerful Orange Pi 5 Plus SBC. That thing boasts an 8-core ARM CPU, also 32 gigs of RAM.
whoa, 32 gigs at an SBC.
Yeah, they're getting powerful. And it has 256 GB of onboard eMMC storage, which is decent. So it's a great blend, right? Repurposed by 86 from the laptop and modern, powerful RM hardware from the SBC.
It really shows you don't need brand new, top-of-the-line expensive gear to get started or even run a fairly serious setup.
Not at all.
So let's break down these low-cost options for your POC. First up, single-board computers,
Yeah.
SBCs like the Raspberry Pi or Orange Pi. What are the key pros and cons you need to weigh there?
Okay, pros for SBCs. They are definite energy sippers, which is great for something running 204/7. They're incredibly tiny, and they benefit from fantastic communities, especially Raspberry Pi.
Right, tons of help online.
The cons are generally limited horsepower compared to, say, a desktop CPU. The RAM is usually fixed. You can't upgrade it later.
What you buy is what you get.
Pretty much. And occasional ARM compatibility issues with certain software, although that's getting much better than it used to be.
Okay. But you mentioned storage is critical with SBCs.
Yes, absolutely critical.
Yeah.
Quan strongly advises avoiding microSD cards for any kind of 247 server workload.
Why is that? They're cheap and easy.
They are, but they just aren't designed for the constant read-write cycles of a server OS and applications. They have a high propensity for corruption and failure. It's often not if they'll fail, but when.
Ouch. Been there, so what's better?
eMMC storage, if the board supports it, is a definite step up in speed and reliability over microSD. But for true server reliability and honestly much better performance,
Yes.
Quan highly recommends SSD boot. Ideally via NVMe if your SBC supports it, maybe through a dedicated slot or a USB adapter.
NVMe. That's that super fast SSD interface, right?
Yeah. Exactly. Significantly faster than traditional SATA SSDs, even. It makes a huge difference for things like database responsiveness or just booting up quickly, starting containers fast. It's worth the investment if possible.
Okay, that's a crucial distinction. I've personally run into those micro SD card failures way too many times in older Pi projects. It's incredibly frustrating.
It really is.
So what if you're dusting off an old laptop instead? What's the deal there? Are they good candidates?
Laptops are surprisingly fantastic for a POC, maybe even underrated.
Really? Why?
Well, they're all-in-one units, right? Screen, keyboard, trackpad included for initial setup. They essentially come with a free UPS because of their built-in battery.
Good point. Power outage protection.
Exactly. They're almost always by 86 compatible, so no ARM compatibility headaches. And they often allow for RAM and SSD upgrades later on.
Okay, downsides.
Downsides are they can be bulkier than an SBC, obviously. They usually have a higher power draw.
Yeah.
And potential fan noise, depending on the model and the load. But for a quick, cheap start, excellent choice.
And old desktops. I mentioned they're the workhorses if you have the space.
Desktops generally offer the most raw power and are typically the most easily upgradable, swapping RAM, adding drives, even changing the CPU sometimes. But they're the bulkiest, can be the noisiest, and usually have the highest power consumption, plus no built-in battery backup like a laptop. Still, if you have one gathering dust, they're very capable, even for heavier POCs.
Okay. What about the newer trend? Mini PCs like an Intel NUC or maybe those B-Link boxes, they seem to be gaining a lot of popularity for home labs.
Yeah, mini PCs are a fantastic middle ground. They're really compact, much smaller than a desktop, often smaller than a laptop. They offer surprisingly good performance for their size and power draw.
Good performance per watt.
Usually, yes. They're by 86 compatible, often upgradable in terms of RAM and SSD, and relatively quiet compared to a full desktop.
Sounds ideal. What's the catch?
The main con is usually the upfront cost. You generally have to buy them new or maybe refurbished on like an old laptop or desktop you might just have lying around. But they are an excellent, versatile platform if the budget allows.
Okay, so boiling it down, what are the recommended specs for a solid POC baseline? And then what if you want to aim for more serious scalability down the road?
Okay, for a solid POC baseline, Quan suggests aiming for something like a quad-core 64-bit CPU,
Quad-core. All right.
about 8 GB of RAM, and maybe 128 GB to 256 GB of SSD storage, SATA or NVMe, preferred over microSD or slow eMMC.
And what can that run comfortably?
That configuration is pretty comfortable for Docker, running multiple containers and even dipping your toes into initial single-node K3's experimentation.
K3s. That's the lightweight Kubernetes, right?
Exactly.
Right.
Perfect for learning Kubernetes without needing massive resources. Now, for a serious scalability focus,
You want to build bigger later.
yeah, if you're already thinking about a multi-node Kubernetes cluster or running more demanding databases, you'd aim higher, maybe 6 to 8 plus powerful 64-bit cores.
More cores.
Definitely. 16 GB to 32 GB of RAM, or even more if you can swing it. And a larger, faster SSD, maybe 256 GB to 512 GB plus ideally NVMe.
That gives you headroom.
Lots of headroom for Kubernetes master worker nodes, bigger databases, more complex services down the line.
And beyond the main box itself, what essential extras should someone budget for or plan to acquire? Things you might forget.
Good question. For SBCs, definitely a quality power supply. Don't skimp here. Unstable power causes weird issues. Proper boot media, like we discussed eMMC, or a reliable USB SSD. And a case, often for protection and maybe cooling.
Right. And for any option.
For all options, you'll absolutely need a bootable USB drive for installing the operating system. Good quality Ethernet cables don't reuse ancient questionable ones. And if you are repurposing an old machine with a spinning hard drive,
Yes.
strongly consider upgrading that old HDD to an SSD. It's probably the single biggest performance boost you can make for relatively little cost. Makes a night and day difference.
Huge difference. Okay, so what does all this hardware discussion really mean for your specific choice for the listener? It sounds like it's about aligning your current resources, your budget, with your specific learning goals for this first step.
Absolutely. It's about being pragmatic, choosing what works best for your specific situation and budget for this initial crucial POC step, not necessarily buying the shiniest new toy.
Right. Okay, let's talk about the brain of your fledgling home data center,
Mm-hmm.
the operating system. Why is Linux pretty much the undisputed foundation for a project like this? Why not Windows Server or something else?
Well, Linux is fundamentally the native home for almost all serious server technologies, especially the open source ones like Docker and Kubernetes.
They were born on Linux, basically.
Pretty much. The vast majority of server software is developed for Linux and runs natively on Linux. This means you're working directly in the environment these tools were designed for.
Which gives you
Immense flexibility and control, especially once you embrace the command line interface, which is essential. Plus, it's incredibly cost-effective. Most distributions are free and open source, and the community support is just massive. Unparalleled, really.
stability, security,
Yeah,
all that good stuff, too.
all of that. It's the standard for a reason.
Okay, that makes perfect sense. But here's where Quan makes a recommendation that seems counterintuitive, at least to me initially. For the POC, he suggests starting with a desktop edition of Linux.
Yeah, like Ubuntu desktop.
Right. Most of us think server. We immediately think headless, command line only, minimal install. Why recommend a GUI for a server POC? Doesn't that just waste resources?
It does use slightly more resources, that's true. But this raises an important question about bridging that gap, right? Between beginner friendliness and powerful server administration.
Right.
Quan's advice to start with a GUI-based desktop Linux, like Ubuntu Desktop LTS, the long-term support version, is purely about lowering that initial learning curve, especially if you're not already a Linux command line guru.
So it's less intimidating.
Far less intimidating. A familiar graphical interface makes those initial interactions much easier. Simple tasks like connecting to Wi-Fi, managing basic settings, even just opening a web browser to look up tutorials or copy commands.
Stuff that can be fiddly on a headless server if you're new to it.
Exactly. You're not battling the OS installation, the basic networking setup, and trying to learn Docker all at the exact same time.
Reducing the number of new things you're fighting simultaneously.
Precisely. You get visual aids, a user-friendly file manager, a simple text editor, and an easy-to-launch terminal. The terminal is still where you'll spend most of your time running commands for Docker and such.
But getting to the terminal and having helpful tools around it is easier.
Right. It allows you to focus your mental energy on the core technologies you're trying to learn, Docker basics, application deployment, without simultaneously battling headless server administration from scratch.
It's like learning to drive in an automatic car before trying to tackle a manual transmission. Learn one major skill at a time.
That's a perfect analogy.
So even though a desktop environment does use a bit more RAM and CPU compared to a minimal server install, the benefit of that gentler introduction outweighs the resource cost, at least for this initial stage.
For an initial POC, especially with the recommended baseline hardware we talked about, yes, absolutely. The reduction in frustration and the potential acceleration of learning are well worth that small overhead.
And you can always change later.
Of course. You can always optimize and potentially move to a leaner, headless setup in later iterations as your skills and confidence grow. This isn't locking you in forever.
Good point.
And Quan specifically notes that future examples, commands, and tutorials in his Chronicles series, and by extension reflecting the Skill Wanderer approach, will primarily feature Ubuntu.
So following along will be easier if you start there.
Exactly. While the core Linux and Docker skills are generally applicable across different distributions, this consistency provides a clear, reliable path for learners. It's part of that curated, guided learning philosophy. Okay, and that brings us pretty much to the culmination of day zero. We've covered a lot of ground just in the planning.
We have.
So you've just completed the vital planning phase. This deep dive has hopefully shown you how to lay that strategic foundation, moving beyond just dreaming to actually creating a realistic blueprint for action.
It was all about that deliberate planning, that honest self-assessment, and setting specific, measurable goals for your first small, achievable step.
And this planning phase, yeah, it might seem less exciting than actually building stuff and plugging things in.
Definitely less flashy sometimes.
But it's what truly sets you up for a smoother, less frustrating, and ultimately much more successful learning journey down the road.
Absolutely. This structured approach, this day zero thinking, is really a hallmark of Skill Wanderer's whole philosophy for empowering learners to tackle complex technical challenges with confidence, not just brute force.
So wrapping up, here's a provocative thought for you, the listener, to maybe chew on. How might the discipline of day zero planning, as we've applied it here to a home data center, translate into effectively tackling other complex projects in your life? Or maybe learning other new challenging skills.
Yeah. Think about that first deliberate strategic step for your next big goal, whatever it might be. That planning can make all the difference.
Definitely food for thought.
And stay tuned. We'll be diving into day one of the Chronicles of a Home Data Center soon, where this blueprint starts to come to life with actual hands-on building.
Getting our hands dirty.
Exactly. And Quan encourages you, if you're embarking on this, share your own day zero plans within the Skill Wanderer community. Connecting with others, sharing ideas, collaborating, it's key to collective growth and learning from each other.